Okay, this is a brand new unit, moles and stoichiometry. And the one thing I can say about this unit is there's a lot of math in it. The last unit we just did, bonding, was predominantly conceptual. You had to memorize things. In this unit, you're using formulas from reference table T and you're doing a lot of math. So in this first lesson, we're going to understand the mole concept. We're going to learn how to calculate formula mass and how it differs from gram formula mass. And then lastly, we will calculate percent composition. Before we can even begin to understand what this unit is about, we need to be able to find the mass of different compounds. So you need your periodic table. First, what are the units we use for the mass of atoms? Well, the units that we use, and we mentioned this in the atomic theory unit, is atomic mass units. And we abbreviate that AMU. So what is the mass of one atom of oxygen? Well, if you look on the periodic table, you see that the mass of oxygen is 15.9994. And that is AMU. We don't use grams as the units because atoms are too small. The number would be very, very bulky. For example, if we used grams to mass atoms, the mass of oxygen would be this number right here, which we could put in scientific notation as 2.7 times 10 to the negative 23rd grams, which is extremely, extremely small because the mass of protons, electrons, and neutrons are extremely small. So let's find the mass of the following atoms. So all you're going to do is look up the mass on the periodic table and then write the units AMU. So example, magnesium is 24.305 AMU. I'm looking these right up off the periodic table. Li is 6.941 AMU. Cl is 35.453 AMU. Al is 26.98154. Calcium is 40.08. And hydrogen is 1.00794 AMU. So all I did was look up the mass and then add the units AMU. Blank elements. One atom of an element that's stable enough to stand on its own. So we have already talked about these two words. This is monatomic, meaning one. Mono meaning one, atomic meaning atom. Elements or diatoms, elements whose atoms always travel in pairs. This should look vaguely familiar, okay? It's Brinkelhoff and bonded to another atom of the same element. So they have this other one in here. We're not going to worry about that. You know this as BR, I, N, Cl, HO, and F, Brinkelhoff. So these are our diatomic elements, meaning two atoms. So what would be the mass of one molecule of oxygen? Well, a molecule of oxygen is written as O2, so it's going to be 2 times 15.9994. And when we do the math on that, we get 31.9988 AMU. So how do we calculate the formula mass and gram formula mass? Well, it's very easy. Formula mass is just the mass of an atom, molecule, or compound in atomic mass units. So what we just did in the previous examples, we were calculating formula mass. Now, if I'm talking about gram formula mass, and this is also referred to, you'll see me do this, GFM. GFM is gram formula mass, is the mass of 1 mole of an atom, molecule, or compound in grams. For example, GFM of hydrogen is 1.00794 grams. This is the mass of 1 mole of hydrogen. 1 mole is 6.02 times 10 to the 23rd units of a substance. So it's like a really big dozen. It's an equivalent. So 1 dozen is 12 eggs. 1 mole is 6.02 times 10 to the 23rd units of a substance. So 1 mole of carbon is 6.02 times 10 to the 23rd atoms of carbon, which also equals 12.0111 grams of carbon. So what you need to know is that 1 mole equals the gram formula mass. It also equals 6.02 times 10 to the 23rd units. And we'll also learn that it equals 22.4 liters if the substance is a gas. So just like we say 1 foot equals 12 inches, that's an equivalent. We can say 1 mole equals the gram formula mass of a substance. Okay, 1 mole of neon equals, we look up neon and we see that it is 20.180. So 20.180 grams. It also equals 6.02 times 10 to the 23rd atoms. And neon is a gas, so it also equals 22.4 liters. These are equivalents. So what is the formula mass of K2CO3? So we need to break this down. K, we have 2 of them. So it's 2 times whatever the mass is. So it's going to be 2 times 39.09 39.0983, and that's going to equal 78.1966. Then we have 1 carbon, so 1 times 12.0111. Oh, I put an extra. Let me get rid of the 1. Okay, so 12.011. And then oxygen, we have 3 of them, 3 oxygens times the mass of oxygen, 18.9994. And that gives me a mass of 47.9982. And then all I have to do is sum these, and I get 138.2058 AMU. Now since I'm adding, I probably would only go to this spot right here because of sig figs. Not going to get crazy on that, so 206 AMU. Alright, let's look at the next one. First thing I want to tell you is anytime you see this in a formula, it does not mean multiply. It means with. So this is copper sulfate with 5H2O. So the whole compound is the whole thing. And they want us to calculate the gram formula mass. So let's see, we've got copper, sulfur, oxygen, hydrogen, and then oxygen again. So copper we have 1 times 63.546. Sulfur we have 1 times 32.065. Oxygen we have 4 times 15.9994. H we have 5H2O, so 5 times 2 is distributive property of math here. 10 times 1.00794. And oxygen again, we have 5 oxygens. So we've got 5 times 15.9994. 33.546, and this is 32.065, but we've got 4 oxygens here, so that's 63.9976, and we've got 10 hydrogens, which is 10.0794, and 5 oxygens, which is 79.997. So then we have to sum these, and it gives us a grand total of 249.685 AMU. Oh, sorry, not AMU. This is going to be grams because it's asking for gram formula mass. Okay, moving on. This is calculating percent composition. First thing you want to do is calculate the GFM for the compound. So here we have 1, so 40.08, and 2 times 35.453. That's going to give us 79.906. And then we get the sum of those, and we get 119.986. But this only has 2, so I'd probably go to 2. So that means that it's 119.99. So now we have the GFM. When you look at table T, last page, you will see formulas listed, and percent composition is mass of part over mass of whole times 100. So we want to use the formula that we just calculated to find the percent composition of each element or part to the nearest tenth. So CaCl2. If we're doing calcium first, my part is Ca and my whole is the whole thing. So we said Ca, so this is percent Ca. So we said Ca was 40.08 over the whole thing, which is the total, 119.99 times 100. And when we do the math on that, we get 33.4%. So that is our calcium. Now they want us to find the percent oxygen. So if I'm going back, not percent oxygen, I want us to find percent chlorine. So here's my part, and here's my whole. So percent chlorine is 79.906 over my whole, 119.99 times 100. So when we do the math on this, we get 66.6%. And this should make sense because there's only two things, and we know it's got to add up to 100%, so 33.4 and 66.6 equals 100%. Alright, we're almost done. I want you to try a couple. So, percent of carbon in CO2. So my part is carbon, and my whole is CO2. First thing I need to do is find the mass of everything. So I've got 1C, and I have 2 oxygens. 2 times 15 point is 31, sorry, 9988. So I need to sum these, and that's going to give me 44.0098. So percent carbon equals 12.011 over the whole times 100. And I'm going to get 27.29% carbon. What is the percent mass of nitrogen in NH4NO3? You gotta be careful on this one, because my part is all of the N, and there's 2 of them, and then my whole is everything else. So let's find the mass of this first. So we've got N, we have 2 of them, times 14.0067. H, we have 4 of them, times 1.00794. And oxygen, we have 3 of them, times 15.9994. So let's do some math here. 28.0134 and then 4 times 1.00794 is going to give us 4.0316, and 47.9982 for the oxygen. And when I get the sum of that, I get 80.0432. So remember, it's my part. So percent N, I have two of them. That's my part. So the 28.0134 divided by 80.0432 times 100. And I get 34.997. I get 34.997, which is approximately 35.0%. N. Last problem. What is the percent by mass of oxygen in magnesium oxide? Well, Mg is +2 and O is -2, so it's simply MgO. So this is my part and this is my whole. So Mg, we've got 1 times 24.305 and oxygen 1 times 15.9994. So all I have to do is add these up and I get 40.304. So for percent Mg, or percent oxygen, it's going to be my oxygen, which is the 15.9994 over the mass of the whole thing, 40.304 times 100. And I'm going to get 36.69. I'm going to get 39.69, which is 39.7%. 39.7% oxygen. And that's my answer. And that's it for tonight's lesson.